Thank you for coming for this presentation. This is essentially a presentation and a journey that we had at eBay. It was a problem that we faced with managing our pen testing queue, what we tried to do about it, and how we ended up optimizing some aspects of our pen test queue. But before that, let me introduce myself. I am Kiran Shirali. I currently lead the use case and correlation logic on the blue team at eBay. This was a very recent change. Just prior to that, I was working on the red team and eBay. It's part of our security assessments group. It takes care of red teaming as well as pen testing. I've also worked on AppSec in eBay. Now, I like finding bugs. It's a passion of mine. I participate in bug bounties. I like poking and prodding systems. And when I'm not in front of a computer, I like to travel and experience new cultures. So that we are all on the same page. I know this is a very basic start, but I want to make sure that I set some context here. What exactly is a pen test, right? It essentially is a simulated attack on the system. The attack is designed to test the security of the system. Now, in eBay, we have a bunch of candidates that come into our pen testing queue, and I'm going to classify them in two large buckets. One is externally facing, another is internally facing. Now, externally facing is anything like ebay.com, what you guys probably see on it when you come to purchase something on it. Internal applications, on the other hand, are not discoverable outside. There may be HR systems, monitoring systems, systems built by our engineers, because we give them a lot of flexibility to be able to automate some of the stuff that they're doing and things like that. Now, our pen test team is primarily, it's got two components. One is our internal pen testers itself, and also external consultants that we engage. And we follow this hybrid model primarily for a lot of reasons, but the primary reason is our ability to flex up and flex down. There are times in a month when you have 10 or 12 pen tests going on in parallel. Sometimes just a few scoping calls. So it helps us to manage our resources more effectively. So the focus of this talk is going to be on these internal systems and not the external system. Primarily, just let me just, so that we are all on the same page, just talk about how an engagement is, right? So typically an engagement for these internal systems is like a 2 or 3 week engagement. You have 1 or 2 pen testers on this engagement. How it goes is that we get a request from team saying, hey, can you pen test my application? Can you pen test my product for me? And again, remember, these are internal applications. And for a company of our size and our longevity, we have a lot of systems that have been built over time that people have not really focused on in a security perspective. So over the last couple of years, we have been trying to seep the culture of security into the company. So anytime there is, say, a movement from a data center to another data center, you're doing a tech refresh of certain systems, we have a requirement saying that you need to go through a security review. And that's why a lot of these teams do come to us, some by choice, some not so much, right? So when they do come in, we have an initial scoping call. The scoping call asks them, what is the system about? Give our pen testers who have no idea about your system a walkthrough, the design and all. Then the actual tests are performed. You go through your use cases, you see the logic around it, you perform your tests. Now, a good pen tester will focus a lot on the report too. It's essentially documenting your work. You want to be as detailed as possible. You want to talk about the steps that you performed and give some suggestions for remediations. And then finally, you have a walkthrough with that team. You tell them what you found, how you found it, how they can fix it. Many times what happens is, once you do this walkthrough with the team, they come back. Say some of them don't agree, or you have sort of a discussion. They go and fix certain things. They come back saying, hey, can you retest those findings for me? So you do step 2, 3 and 4 again. So and in some cases you have scenarios wherein they've not remediated stuff properly. You will have to do a remediation test on the remediation test. So it's sometimes an endless loop. But again, so the bulk of the pen test that or pen test requests that we get is on these internal systems, right? Because just as I've said before, there's just too many numerous systems. We are essentially a developer shop, so we give the flexibility for our engineers to build in any language, any platform that they want internally. And so these systems are so different from each other that it's hard to set, very unique standards for each of these systems. But at the same time, because the systems are relatively small and not humongous like ebay.com, you don't need a lot of context to be able to do this quickly. So you can scope some of these systems in 2 to 3 weeks in those buckets. And that's why we engage our external consultants, a part of our team, mostly on this section. But that becomes pricey very quickly, right? It's a lot of cost. And again, some of these systems, they're just too small for a secure SDLC process. Or else they might be third-party systems that have not been built by us. We don't have access to the source code. We only are able to configure certain things on these systems. So if you have ever seen a pen test report, these classifications of vulnerabilities won't be unfamiliar to you. This is generally what we see across our reports. But there's one pattern in this that I would like to focus on. Essentially, misconfiguration issues, encryption issues, rate limiting issues, security headers. And in a lot of our reports, we keep seeing these statements peppered across, right? TLS version is outdated, insecure ciphers, right? Your cookie flags, or a couple of security headers are being used but not being used properly. So 20 to 25% of our findings on the final reports are essentially those kind of issues. And a good friend of mine, termed this very nicely. He said these easy to find issues, they're essentially true positive pen test noise, right? As a pen tester, I'm motivated and challenged to find the business logic flaws. Now, don't get me wrong. The issues that were given up there, they're important to find too, right? They're important to get them remediated too. But as a consumer of the report, as well as a pen tester, I believe there's more bang for buck when you have your team focusing on that business logic flaws and not these easy to find flaws. So, and also because they're all external consultants, it's money that we are essentially burning away in our perspective. So we thought a year back, how do you optimize? What can we do to fix this problem, right? So initially what we said is, let's do checklists, right? We don't want to reinvent a secure SDLC process. It's just a checklist of maybe 10 or 15 things, right? And every time somebody came to us for a pen test, we said, here's the checklist. You need to go through this checklist and make sure that you're doing everything on the checklist. If you're not, we won't pen test you. So your timelines, if you've got timelines for a particular program, not our problem, right? So we even, to evangelize it, we wrote pre-canned configuration files for Nginx, for Apache, for Tomcat. We tried evangelizing all of this. Now the problem in the self-certify model is, people came back saying, we've done all of this, every single one of them. And we went and did the pen test, and we saw that our results were not really changing, right? They kept coming in there, and it's a set of problems. Some of these folks don't really understand security so much, so they go in and they don't know what in that checklist they need to apply to their systems. Some of them are doing these changes, but not effectively. And some are telling us they're doing those changes, but somehow it all magically just disappears when it comes to a pen test, right? So we went back to the drawing board and essentially wanted to build something or do something that will help us solve this problem, right? Now, there was one idea. Do we buy another fancy tool? No more tools, right? No more buys. Let's not buy something. We need something also that was quick. anything that our PD team need to spend more than 1 minute, 60 seconds on was something just not acceptable to us, because we, again, as I said, we didn't want to reinvent the wheel or reinvent the secure SDLC process, which we already have for a lot of our applications, especially our external facing applications. Also, we wanted something that's very easy, simplified, so people don't crib about how difficult our new process is, right? And that's when we built Hunter. So what is Hunter? Hunter is a lightweight tool to audit for easy to find security vulnerabilities. I know, another tool, but something that fit our requirements, right? It essentially grades your HTTP endpoint between an A to C grading. We will add some more grades up to F, but right now there's a few rules that it checks for. And before I step into what it audits for, let me tell you what Hunter is not. It is not a replacement for our secure SDLC process, and if you decide to use it, it shouldn't be a replacement for yours, right? It has to be just a prerequisite before you engage or before a team engages you in your pen test, right? Also, it's not another tool for pen testers. It has been very simplified. It's a quick grading tool just for your product teams. Now, what does Hunter help us audit? It checks for SSL versions, TLS versions. It's got a weighted priority for older versions, weighted penalty for older versions. So the older the version that's enabled, the more it docks points, lowers your grade. Checks for your configured ciphers. It checks for some of these strict transport security headers. Checks for common mistakes that we are seeing when people configure their headers. And it's all based on our guidelines or what we recommend to our teams. Again, in CSP, one thing that we always see, people put it in and then they put unsafe eval in there. So things like that. Again, a few more of the headers and cookie flags, right? So at a very high level, it's Python-based code. We have a wrapper around, and we basically use SSLIs by Albin from Data Theorem. It's Django and Django REST framework based. It uses a couple of Python libraries. So in an architecture perspective, at a very high level, our users interact with a UI. It's a front-end UI that's very simple. I will show it to you in a minute. The front-end UI interacts with the back-end via REST. And while the server has a couple of components, the two most important ones is a scoring module as well as a audit module. The names are self-explanatory. Our audit module does those audit checks that I've talked about. The scoring module scores based on the results. Now, one thing I would like to note is right now the scoring module is kind of built into that. The scoring parameters are built into the module. We want to pull that out so that it's more configurable, because something that's important for us might not be important for you, right? So that's work in progress. Let me quickly show you a demo. So here's how Hunter looks like. Like I said, it's simple, right? The simple one text box that they have just given HTTP endpoint. There's one button. So if anybody comes back to me and says, this is complicated, I'm like, really? Right? So I do have 1 or 2 links up here that essentially is a help and contact. Now the help files is there's a bunch of links in there that internally we use it to our pre-canned configurations. We have some of our own support pages that helps people fix certain things in an eBay way. Now in the open source code, we have put in some of that data onto a GitHub link, so it's configurable. Now I'm going to test it against a particular site. I'm hosting it locally. It's just a simple web page. The reason is security conferences and the Wi-Fi. I'm just not comfortable inherently. All right, so this local application has all the protections that you ideally would want an internal application maybe to have, especially if you're thinking of upping the security. So let's go back there. Fingers crossed. Oops. And yeah, so under what, 3-5 seconds we get results. And right now, of course, it's a local host, right? We've done some tests with internal applications, we've done tests with external applications. Under 30 seconds, that was our primary concern. Now this particular rating is the best possible scenario, right? You have TLS 1.2 enabled, you have all the relevant headers that's required. In our perspective, there's a few more things that we do with respect to eBay that's not up here. We've removed that off, and it's again very configurable if you want to add in a couple of more modules. Now, before this presentation started, I did a few tweakings on that test site and changed or removed some of the protection. So, and I'd ran Hunter next to it. So, I had run Hunter on it. So essentially, this is a scenario wherein you get the worst rating so far. Like, SSL 3.0, it's just a big no for us. We just we're going after teams that have this internally enabled. We are also actively discouraging TLS 1.0 and 1.0 and 1.1. None of the security headers in place. So the best case scenario and the worst case scenario, there's not a lot of systems that come in with that. That's good. Most of the times, the bulk of our applications that come in for pen tests come in a scenario like this, wherein it's like a mid-level rating. They've got some protections in place, like they've disabled SSL 3.0. They've got 1.0, 1.1 enabled. They've also got 1.2 enabled. They have a few of those headers in place, but they're making mistakes in terms of when they put the headers in place. So this is like the bulk of stuff that we see. And we have a policy now internally. We say unless you get an A grade on this tool, in the audit tool, we will not pen test you. So it helped us reduce the folks that said, yes, we fixed things, but they didn't really fix it. They didn't know how to fix it. Maybe it started reducing those pen test noise, as we call it, right? And helped us increase optimization within our team. So I'm going to stop for a second here and ask, does anybody have any questions? Do you want to give the, okay, sure.
What issues does this tool look for specifically? Like just the TLS, some headers, or also the general application security bugs?
No, it's not for the general application security bugs. It's very, as I said, very stripped down, because we didn't want to reinvent the wheel, honestly. And in some essence, at a very low level, we have a full secure SDLC process in place, and that's got a full comprehensive set of processes. This was more intended just to have those basic audit levels, audit checks, to prevent the pen test noise. And we didn't want to buy some new fancy tool. That's our primary reason.
How does your scoring module works?
So right now the scoring model is, the question was, how does the scoring model work, right? So right now the scoring module is pretty simple. We have a weighted average based on what we think is important, and SSL versions right now have the worst weighted average. Like docs on a 100% perspective, it docs about 20-25% off your score. The other ones are more, they're lesser. It's in a few percentages, single digits. Again, one of our immediate releases will pull this model out and give it in like an admin page, or maybe a config file that you can go and tweak the way you want it.
Yeah.
I was just curious how much you're looking for from the CSP policy portion. Like, are you just looking for the presence, or do you guys have a specific policy you're trying to push forward for these teams?
So we right now, that's a good question, by the way. We don't do an extensive check. We're just looking for the presence, and we're making sure that they're not adding in unsafe eval, and that's one of our primary concerns, because many times we have seen that we are recommending it internally to our teams as a test bed, and we see that they just add in these unsafe eval just to get away from the protection or for ease of use.
Outside of the TLS versions that you're capturing, do you have like a list of preferred encryption algorithms or ciphers that you're flagging, or are you just kind of listing the encryption algorithms that you're currently supporting?
So right now we have an internal set that we recommend. So you're not flagging any ciphers as of yet, but we are recommending that our teams use the cipher list that's approved, and that's what comes up as in our help pages. Also, just adding to that, right now in our help pages, in the open source stuff that I post, I have links to those configuration files that we evangelize internally. So we've already published it on GitHub. You can see some of these details in there.
So if I had preferred ciphers, then I might be able to whitelist or blacklist if I were to configure it as such.
Yeah, you can flag it. Yes.
So you mentioned that you have a lot of legacy applications, but you also have an SDLC process in the company. So I can see how probably lots of applications got deployed into production prior to that SDLC being in place, or maybe there weren't the same kind of QA processes there before release into production. Is this integrated now into that process so that before a new system gets released in production, they have to pass this as a minimum, and or even your internal pen test? And
So-
then is it going to like kind of die out eventually once those processes are matured?
That is actually the hope, that it will die out at some point. So we do have a extensive secure SDLC process, and we have this as one of the prerequisites in there. Now the problem with that approach is that sometimes some of these internal applications, there's no access to the source code, for instance, right? It could be just a off-the-shelf software that needs to be configured and all. In those cases, there seems to be not a lot of value in the secure SDLC process. A lot of the portions get skipped. And that's when we have them go at the minimum of this and a pen test, so that we are at least checking to see if everything is well within our standards. Now, again, as I mentioned, a lot of those older legacy systems, we are being pragmatic. We won't be able to go after them all within this year, right? As they get decommissioned, new ones come up, or they're being moved around, we are hoping to target all of them. Did I answer your question? Okay.
How did it affect the pen test results by external contractors? Did you start getting better results?
Yes. So we started reducing our fines of this sort by a considerable number. Unfortunately, I cannot share that number. We had an internal review of this thing, but it was a considerable amount. Especially among internal systems, it's higher double digits. In the external system, overall, because we do. So see, if you're doing about 5 to 10 pen tests a year, this is not a big concern. If you're doing about 50 to 100, it's a rising concern for you. If you're close to about 300, it's a big concern, right? So it was a significant amount for us.
You mentioned like a pen test queue that your internal teams were kind of working against. Can you describe, like, by just implementing this, like what did that enable your pen test teams to do then? Did they focus on business logic? Did that make them do like more pen tests? Like what was the effect of just implementing these prereqs that you described?
So it was a combination of two things. One is our scopes, or at least the time that we took for doing pen test, started actually dropping. Because you see, when you find something, you need to document it. That takes time. You need to present it to the team. That also takes time, right? And then what happens is we need to hold on to these resources because we'll want them to come back for a remediation pen test. And that also takes time. So in all of these scenarios, by reducing these fines, actually the number of pen tests that we could do within a period of like a month or two started going up for us. The converse of it is also we started having more challenging work for our consultants. Folks wanted to be engaged. They liked the variety. They saw that they didn't need to really deal with the pen test noise. So it was a two effects that was positive for us. Any other questions? Okay, let me just go quickly back to the presentation. I have just a few more slides, and I guess I'm going to leave you guys early for lunch. Oh, that worked. So you can look at Hunter on my GitHub link. I'm open to pull requests. If there is any features that you think is important that we can all use, message me. We could probably put it on our roadmap. It's a personal pet peeve for me, personal pet project for me. Also, I'm right now I'm cleaning up a little stuff. It's functional, but there's always scope for improvement. So you'll see a couple of pushes out over this week. So yeah, please use it if you think it's applicable for you. Let me know. Give me feedback. We have some future plans. As I mentioned before, we want to pull the scoring out of the module. We want to put it on maybe an admin page. We still haven't decided. But that's currently work in progress. We want to integrate it with LDAP or single sign-on, primarily because we want to know what are the requests that are coming in, and we want to save these scan results. It's like a history. Also, based on the saved results, we want to maybe periodically go check things again at a later stage, because sometimes things get rolled back, and maybe there's a follow-on pen test 6 months later, and we see, hey, didn't we really fix this the last time? So we want to prevent such scenarios. We also are looking to start identifying self-signed certs. Also, internally, we have a CA for our internal applications. We want to be able to say or push for adoption for that CA. And yeah, these are our future plans. Again, if anybody has any questions, I know I did answer a couple of them, but guess I'm going to give you back almost 20 minutes of your time. Thank you, everyone.